Your brand new Ford truck or SUV is rolling off the assembly line with factory settings designed to quietly destroy your engine and drivetrain long before you ever hit the 100,000-mile mark. Most owners have no idea that the very features marketed as advanced engineering are actually Trojan horses designed to help Ford meet strict government regulatory mandates at the direct expense of your vehicle's longevity. You think you bought a machine-built Ford Tough, but out of the box, it is programmed to sacrifice its own hardware to shave fractions of a % off emissions and fuel economy targets. Today, I am exposing 5 factory settings and features that are inflicting hidden damage on your Ford without you ever knowing. Setting number 3 has caused more catastrophic engine failures in my shop than almost anything else. And setting number 1 is so deceptive that owners actually think it is beneficial when it is doing the exact opposite. If you want your vehicle to last, you need to understand what these settings are doing behind the dashboard and how to override them. Let's get into it. Number 5. The Auto Start Stop Factory Calibration Setting number 5 is the ubiquitous Auto Start Stop feature. Ford programs this system to shut down your engine every single time your vehicle comes to a complete stop, whether you are waiting at a traffic light for 2 minutes or pausing at a stop sign for 2 seconds. Ford's marketing tells you this feature saves fuel and cuts tailpipe emissions. What they don't tell you is the brutal mechanical toll this constant cycling takes on the internal components of your engine. In a standard modern engine without this system, a driver might start their vehicle 2 to 4 times a day. With Auto Start Stop active in heavy stop-and-go traffic, that number skyrockets to 30, 40, or 50 start cycles in a single commute. Here is the hidden mechanism that Ford doesn't want you to calculate: hydrodynamic lubrication. When your engine is running, the oil pump creates pressure, forcing a microscopic film of oil between the crankshaft journals and the rod bearings. Your engine bearings literally float on a cushion of oil, preventing metal-on-metal contact. The moment that engine shuts off at a red light, oil pressure drops to 0. The heavy crankshaft settles, squeezing out that protective oil film. When the light turns green and the starter engages, the engine experiences a brief moment of boundary lubrication, meaning metal is rubbing directly against metal before the oil pump can repressurize the passages. I have personally inspected rod bearings on EcoBoost and Coyote engines with fewer than 50,000 miles that were driven exclusively in city environments with start-stop enabled. The overlay material on those bearings was completely gone, worn down to the copper lining. This system is effectively grinding your engine bearings to dust, one traffic light at a time. Furthermore, the constant cycling causes severe thermal cycling in the turbocharger center housings on EcoBoost models, cooking the residual oil into hard carbon deposits, because the coolant and oil pumps stop circulating the moment the engine dies. The solution to this is simple but requires a change in habit. Every single time you climb into your Ford and hit the ignition button, your very next action must be to press the Auto Start Stop Disable button on the dashboard. Do not let the vehicle cycle itself off. If you want a permanent fix, look into an aftermarket start-stop eliminator plug that installs behind the switch to remember your preference. Or disable the feature entirely using diagnostic software like FORScan. You might sacrifice a negligible fraction of a mile per gallon, but you will save your crankshaft, your starter motor, your battery, and thousands of dollars in premature engine replacement costs. Number 4. The 10R80 Transmission Adaptive Learning Protocol Setting number 4 is a software protocol that Ford markets as a high-tech benefit. But under real-world conditions, it creates the exact environment that destroys your transmission. If you drive a modern F-150, Mustang, Explorer, or Expedition, your vehicle is likely equipped with the 10-speed 10R80 automatic transmission. From the factory, this transmission relies on an adaptive learning algorithm. Ford claims this software monitors your specific driving style and adjusts shifting pressures and timing over time to provide the smoothest possible gear changes. Here is the mechanical reality behind that marketing fluff. The adaptive learning system is heavily weighted toward fuel economy and corporate shift comfort targets. To achieve those imperceptible shifts that consumers expect on a test drive, The transmission computer commands the internal clutches and bands to slip into engagement rather than locking in place firmly and cleanly. It uses low fluid pressure lines to create a prolonged, soft engagement window. When a clutch pack slips under load, it creates immense friction and extreme localized heat. This heat shears the transmission fluid, breaking down its viscosity and oxidizing the friction modifiers. Worse yet, as these clutches slip, they shed microscopic friction material directly into the fluid. This contaminated fluid then circulates through the ultra-tight tolerances of the main valve body. In my shop, I see the catastrophic results of this protocol daily. The valve body bores wear out prematurely due to the abrasive debris, causing the small control valves to stick. Once those valves stick, the transmission begins exhibiting erratic behavior, harsh 1-3 upshifts, violent clunks when dropping into reverse, or a total loss of gear engagement during highway acceleration. Ford's factory programming forces the transmission to continuously adapt to its own internal wear, masking the symptoms of a failing valve body until the unit finally destroys its own internal gear sets or burns out a clutch pack entirely to save your 10-speed transmission. You need to intervene before the software programs the mechanical components into an early grave. First, have a qualified technician, or use a tool like ORF or Scan yourself, to completely clear the transmission adaptive learning tables and perform a manual solenoid strategy relearn. This resets the computer back to its baseline parameters. Second, if your driving consists of towing, heavy payload hauling, or aggressive city driving, do not let the transmission default to its standard normal mode. Switch the vehicle into tow haul or sport mode. These factory drive modes alter the shift strategy, commanding higher line pressures and faster, crisper clutch engagement. A slightly firmer shift is a healthy shift. It means the clutches are locking together instantly rather than dragging against each other and cooking your transmission fluid. Stop letting the software prioritize artificial smoothness over mechanical survival. Those first two settings are bad enough, but they are just the warm-up act for how factory programming actively shortens your vehicle's lifespan. As we climb higher up this countdown, the engineering compromises become significantly more severe, moving from component wear straight into catastrophic, non-repairable engine damage. Number 3. The Integrated Intelligent Oil Life Monitor. Setting number 3 is the Factory Calibrated Intelligent Oil Life Monitor, or IOLM. Ford programs this system to look at your mileage, engine operating temperatures, and idle hours to calculate when you need an oil change. On paper, it sounds highly sophisticated. In reality, the algorithms are aggressively tuned to stretch service intervals out as far as physically possible, frequently flashing the change engine oil light only after you have driven 7,500, 10,000, or in some extreme highway cases, up to 12,000 miles on a single fill. Ford does this to advertise a low total cost of ownership to fleet buyers and consumers who look at maintenance schedules as an annoyance. Here is the mechanical truth that I see written in scored metal and broken components every single week. In modern EcoBoost engines, the engine oil does not just lubricate the crankshaft. It acts as the hydraulic fluid for the variable cam timing, or VCT, phasers, and it cools the turbocharger bearings that spin at over 150,000 revolutions per minute under intense exhaust temperatures. When you stretch your oil changes out to 10,000 miles, the oil undergoes extreme thermal shearing. The continuous heat from the turbos breaks down the long-chain polymers in the oil, dropping a 5W30 weight down to a water-thin 20 weight or lower. Worse yet, direct injection engines naturally suffer from fuel dilution. Microscopic amounts of raw gasoline wash past the piston rings during cold starts and mix into the oil pan. By the time that intelligent monitor tells you it's finally time for service, your oil is severely contaminated with fuel, soot, and carbon. This thin, fuel-diluted oil completely loses its film strength. The immediate casualty of this factory setting is your timing chain and VCT system. The timing chain relies on hydraulic tensioners powered by oil pressure. When the oil thins out and becomes contaminated, the tensioners lose pressure, allowing the timing chain to whip and stretch. The elongated chain alters the mechanical timing between the crankshaft and camshafts. I have pulled oil samples from EcoBoost engines running on 10,000-mile factory intervals, and the iron content, which indicates timing chain wear, is consistently off the charts. Eventually, you start the truck one morning and hear a violent 2-second rattling sound from the front cover. That is the sound of stretched chains slacking against plastic guides. Ignore it a little longer, and the chain jumps a tooth on the gear, sending the valves crashing straight into the pistons, instantly transforming your high-tech engine into a $10,000 piece of scrap metal. The solution here is absolute. Completely ignore the digital oil life percentage on your dashboard. Do not wait for the truck to tell you when it's hungry for clean oil. For any turbocharged EcoBoost engine, you must establish a hard ceiling of 5,000 miles or 6 months, whichever comes first. If you drive a naturally aspirated Coyote V8 or a Power Stroke diesel that sees heavy idling or towing, drop that interval to 5,000 miles as well. Always use a premium, full synthetic oil that meets Ford's strict WSS M2C961A1 specification, and pair it with a high-quality filter containing a silicone anti-drainback valve. By overriding the factory's long-drain marketing trap with old-school, disciplined maintenance, you keep your hydraulic tensioners pressurized and your timing chains tight for the next 200,000 miles. Number 2. The active grille shutter Aero First Control Logic Setting Number 2 is the active grille shutter system, controlled by the powertrain command module. From the factory, your Ford truck or SUV is equipped with motorized plastic slats situated directly behind the main front grille, right in front of the radiator and the turbocharger intercooler. Ford's programming commands these shutters to remain completely closed as much as possible during highway cruising. The marketing department boasts that this feature reduces aerodynamic drag, which helps the vehicle post slightly higher highway fuel economy numbers during EPA testing. But here is what Ford does not print in the sales brochures. By prioritizing a microscopic aerodynamic gain, the factory programming deliberately starves your entire engine bay of fresh, cool airflow. When those shutters are closed at 70 miles per hour, underhood temperatures skyrocket. This is not a minor temperature bump. We are talking about creating a literal furnace environment directly around your ignition coils, electrical wiring harnesses, plastic connectors, and cooling system hoses. The hidden mechanism at play here is thermal soaking. In EcoBoost models, the closed shutters force the turbochargers to work significantly harder because the air entering the engine through the intercooler is already superheated. To compensate for the scorching intake air temperatures, the engine control unit has to pull ignition timing and dump excess fuel into the cylinders to keep the pistons from melting due to pre-ignition. This completely destroys the fuel efficiency the system was supposed to save in the first place. For the V8 and diesel models, the consequence is severe, localized heat stress on the back cylinders, specifically cylinders number 4 and 8, which sit closest to the firewall where heat naturally traps. The coolant entering the engine block cannot dissipate heat fast enough because the radiator isn't receiving adequate face-on air volume. Over months of highway driving with the shutters slammed shut, the plastic components under your hood become brittle as glass. The radiator end tanks, which are made of composite plastic crimped to aluminum, expand and contract violently under the intense thermal cycling. In my shop, the #1 cause of sudden, catastrophic coolant loss on late-model Fords is cracked plastic turbo coolant lines and separated radiator seams, failures directly traceable to an engine bay that is constantly baked at extreme temperatures because the factory settings refuse to let it breathe. The solution to this design flaw is physical intervention. You can permanently override this Aero First programming without triggers or warning lights on your dash. If you look behind your front grille, you will see the shutter assembly and its electronic actuator motor. The permanent fix is to carefully unclip and remove the individual plastic shutter blades themselves, while leaving the electric motor plugged into the wiring harness. By removing the blades but keeping the motor intact, the vehicle's computer thinks it is still opening and closing the system, so it won't throw an engine code or lock you out of your cruise control. But structurally, the air path is now permanently wide open. Your radiator, intercooler, and engine bay will receive a continuous, massive rush of ambient air every second you are moving down the road. Your intake temperatures will drop drastically. Your plastic components will stop cooking to a crisp, and your cooling system will finally have the capacity to protect your engine under heavy load. We have fought our way through programming that destroys your bearings, slips your clutches, stretches your timing chains, and bakes your engine bay to a crisp. But none of those features compare to the absolute deception of the #1 factory setting on this list, a feature that nearly every single Ford owner looks at daily and completely misinterprets, while it actively masks catastrophic failures until it is too late to save the machine. Number 1. The artificial buffered dashboard gauge strategy setting. Number 1 is the factory-calibrated buffering strategy for your vehicle's critical dashboard gauges, specifically the engine coolant temperature and oil pressure displays. When you sit in the driver's seat of a modern F-150, Mustang, or Explorer, you see a neat layout of needles or digital bars meant to give you real-time data on your engine's health. Ford's corporate intent behind this setting is psychological comfort. They do not want drivers seeing needles fluctuate during normal operation, which leads to unnecessary service visits from worried customers. So, they program the instrument cluster to lie to you. Here is the mechanical deception that makes this the most harmful setting on your vehicle. Your dashboard gauges are not actually real-time indicators directly wired to sending units. Instead, they are completely managed by the body control module and the engine computer through a heavily dampened software buffer. Take your oil pressure display, for instance. On almost every modern Ford vehicle, that gauge is nothing more than a glorified on-off switch disguised as a needle. The sending unit on the engine block is a basic pressure switch that triggers at roughly 5 to 7 pounds per square inch when you turn the key and the engine builds a measly 6 psi of oil pressure. The computer sends a signal to the dashboard to move the needle right into the dead center of the normal operating zone. Whether your actual oil pressure is a healthy 45 psi or a dangerously low 8 psi, that needle sits exactly in the middle, perfectly still, giving you a completely false sense of absolute security. The coolant temperature gauge uses an equally deceptive dampening curve. The factory programming creates a massive, dead zone right in the middle of the gauge. From roughly 165 degrees Fahrenheit all the way up to 230 degrees Fahrenheit, the needle stays completely stationary right in the center. Your engine could be climbing rapidly from a comfortable 190 degrees up to a scorching 225 degrees due to a failing cooling fan or a slow coolant leak, but your dashboard will show you absolutely zero change. The software freezes the gauge to keep you calm. By the time the factory programming finally decides to release the buffer and slam the needle into the red zone, the damage has already crossed the point of no return. The cylinder heads have already warped, the head gasket has already blown, and the pressurized coolant is already washing into the combustion chambers. I have sat in customer trucks where the engine was literally melting itself down from a severe overheating event, and the factory gauge didn't budge until the engine began to severely misfire and drop into limp home mode. Ford's programming prioritizes a stress-free consumer experience over giving you the vital technical warning signs needed to save your engine from total destruction. To defeat this deception and protect your investment, you must find a way to access the true, unbuffered data flowing through your vehicle's communication network. The simplest change in behavior is to ditch the factory dashboard layout entirely when monitoring your vehicle under stress. You can plug a cheap Bluetooth OBD2 adapter into the diagnostic port under your steering column and sync it to an app like Torque Pro or OBD Link on your smartphone. This allows you to build a custom digital dashboard that reads the raw, unedited sensor data directly from the cylinder head, temperature sensors, and oil pressure monitors, when you can see that your true temperature is climbing past 220 degrees while climbing a steep highway grade with a trailer. You can proactively pull over, let the truck idle, and investigate a cooling issue before the factory dashboard gauge ever wakes up from its programmed slumber. Conclusion: when you look across the entire modern Ford vehicle lineup, it becomes undeniably clear that the engineering teams know how to build incredibly robust, heavy-duty mechanical hardware. The blocks are stout, the pistons are tough, and the capabilities are unmatched. But the corporate legal teams and emissions compliance software programmers have shackled these machines with factory settings that value short-term regulatory targets and artificial showroom comfort over long-term mechanical survival. From grinding down your bearings with start-stop cycles, to slipping your transmission clutches for a smoother ride, to hiding severe temperature spikes behind a fake dashboard gauge, the factory programming is actively working against your vehicle's longevity. You do not have to let these factory settings dictate the lifespan of your vehicle. By understanding the mechanical reality behind these hidden features, you hold the power to intervene. Disable the start-stop system on every single drive. Force your transmission into modes that command firm, healthy clutch engagement. Reject the extreme 10,000-mile fluid intervals in favor of a disciplined 5,000-mile schedule. Open up those active grille shutters so your engine bay can finally breathe, and use external monitoring tools to keep an honest eye on your true operating data. If this deep dive gave you the actionable insights you need to protect your truck or SUV, make sure to subscribe to the channel so you never miss another real-world mechanical breakdown, and share this with an owner who needs to know what is actually happening behind their dashboard. Take control of your maintenance, override the factory compromises, and turn your machine into the truly indestructible powerhouse it was engineered to be. Stay safe out there, keep your fluids clean, and I will see you on the next one.